Hello. In this video we're going to continue our discussion of the anodized parts continuous improvement project. And as you recall, to this point the team has now clearly identified important relationships among the important critical to quality characteristics, or CTQs. That is thickness, L star, A star, and B star, which we've thoroughly discussed earlier. And at this point, using data that is available from the process, they have been able to set specifications for each of these four CTQs such that if they can hold each of these characteristics within these specifications, they should be able to produce anodized parts of acceptable quality. But they have a problem. They don't really know how to run the process in order to achieve these goals or targets for the CTQs. So basically what they need to do at this point is find some way of establishing relationships between what we'll call the hot X's, the key process factors, and these responses, and then try to develop a model using design of experiments which will help us find a way to run this process basically to produce good parts. Okay, so basically what we're going to do is go back to some work done in the define phase with cause and effect diagrams. And remember, a lot of these tools, although we put them in different areas of the define phase, typically are used in more than one area. So cause and effect diagrams are often used in the define phase, could be used in the measure phase, and often are used in the improve phase. So basically, if we go back and we look at prior work that was done, they actually identified 5 process factors that could have a strong influence on the quality characteristics of the parts. So they actually focused in through a cause and effect matrix on acid concentration, anodized temperature, anodized time, dye pH, and dye concentration. And remember, this is a 2-step process. First, the parts are anodized, then they're removed from the anodized tank, and then they're put in a dye tank where the dye then seeps into the pores in the anodized surface, and this is where they establish the black rich color required for the parts. Okay. So at this point we've established 5 factors that we would like to experiment with, but there are going to be some issues. Number one, the experiment will have to be run on process equipment, and this process equipment is literally tied up all the time trying to produce product for the customer because the yields are so low. They're running large backlogs and they're running 24/7. So whatever experiment they desire to use, they're going to be limited. And furthermore, I won't go into too much detail here, they're limited to stay within a range of 10 to 12 runs. In other words, the different trials in the experiment are constrained to, say, the 10 to 12 range. So I'll let you read some of this information on what are called fractional factorials. They're really a bit beyond the scope of what I want to discuss. And I'm going to focus on, in slide 7, where I mention that basically the constraint they had is that they need 12 runs, and by negotiating they were given roughly 9 hours on Sunday night to Monday morning, in other words the graveyard shift, to run their experiment. So what I'm going to do next is go through a couple of sets of notes to give you some background on design of experiments and a flexible way to design experiments in JUMP. Design of experiments is necessarily a large topic. We routinely, which means every semester, teach a design of experiments course, which is Math 740 or 840, and occasionally we teach a second semester with more advanced topics. And by the way, those are extremely popular courses, especially Design of Experiments 1 or Math 740, 840, and is routinely has a very large enrollment from engineering and many of the area of sciences. So at this point, I'm going to give you some background in Design of Experiments, and then we're going to come back and take a look at the experiment they designed for the anodizing process, and then we're going to look at how we analyze it and how to interpret the results.